Hey there, it's Workbench with Workbench Quagmire, back with our Free Code Camp Python certification in 100-ish days. I believe we are on day 69. Could be wrong about that. If I was, there'll be a little annotation on the screen. We're pretty far into this, so we're almost 70% done, and we're kind of getting to some real meaty topics here. So that last video took a little longer. This one might as well. So we're just going through the theory sections and our algorithm portion of this certification through the little learning things with our quizzes. So let's get started with what are good problem-solving techniques and ways to approach algorithmic challenges. During your learning journey, you should work on developing strong problem-solving skills. These core skills will be essential for tackling real-world problems in your daily work. Solving algorithmic challenges is a great way to practice. This requires an analytical way of thinking, being able to break the problem down into its core components and finding a solution that generates the right output efficiently. But where do you start? There are several problem-solving techniques that you can use to start approaching these challenges. Here's an example. As an example, we'll reverse a string in Python. This is the challenge. Given a string, write an algorithm that returns a new string with the characters in reverse order. The first thing that you should do when you come across this type of problem is to read the description multiple times to make sure that you understand what it says. You may miss critical information if you skip this step and read it too fast. So, given a string, write an algorithm that returns a new string with the characters in reverse order. Then once you're familiar with the problem, start breaking it down into its core components. Ask yourself, what is the input? What is the expected output? How can I transform the input into the expected output? In this problem, you can determine that the input is a string because the challenge starts with given a string. The output is a new string with the characters in reverse order. So we need to take the original string and reverse it. This initial analysis might seem a bit too repetitive at first, but it's very helpful to make sure that you fully understand the requirements. Then you should start by thinking about how the algorithm that you will develop will transform the input into output. During this planning and analysis phase, it's common to use pseudocode to map out the necessary steps. Pseudocode is a high-level description of the algorithm's logic that is general in nature and not based on any specific programming language. Pseudocode is not as formal as actual code, since it only is intended for humans to read. It should be easy to understand, and at a glance, its main purpose is to give a clear idea of the sequence of steps that will be performed. Pseudocode is usually a mixture of common written language like English with programming constructs like if, else, for, and while. This is an example of pseudocode that you might write to solve the reverse a string challenge. Get original string. Set reverse string to an empty string. For each character in original string, add character to beginning of reverse string. Display reverse string. Note how the steps are outlined in a way is easy to understand. The words and constructs themselves might vary depending on the standard that you are following. If you want to, you could implement these steps in multiple programming languages following the same logic, since the pseudocode is independent of the programming language. By this point, you may have already realized that the problem can be solved in many different ways. This isn't the only way to reverse a string. But remember that choosing the right algorithm is important. In a previous lesson, you learned about algorithmic complexity and why it's important to choose algorithms that are efficient in terms of time and space. That's where you will play a vital role as a developer. You will need to choose the most efficient algorithm to solve the challenge. Thinking through the available algorithms is an important problem-solving skill that you should practice. Take a moment to ask yourself if the solution that you are proposing in your pseudocode is the best one or not. For example, there are many different algorithms for sorting elements, but some of them are more efficient than others. Bubble sort, for example, is very efficient for sorting large lists, while quicksort is usually more efficient. Or bubble sort is very inefficient, where quicksort is more efficient. For our reverse a string challenge, we could use either one of these approaches, assuming that we are planning to implement our algorithm in Python. Using the extended slice syntax, so the beginning, end, and kind of intervals, with the -1 meaning we start at the end and go forward. So to get a new reverse string. Looping over the characters from left to right and adding the new characters to the beginning of the new string. That was the pseudocode we looked at. Calling reversed function to get an iterator with all the characters in reverse order, and then join method concatenate them back into a string. Which one should you use? That's your choice. Making these decisions based on your knowledge and experience can make a huge difference in the final performance of your application. Considering different approaches, their efficiency, and implications and implementations. Ask yourself, how will I approach this problem? What data structures will I use? Are the data structures that I choose the most efficient ones for the problem at hand? Am I covering all the possible edge cases? Edge cases are specific valid inputs or conditions that occur at the boundaries of what an algorithm should handle. For example, in the reverse a string challenge, as the edge case should be taking an empty string as input. Are you handling this correctly? If not, consider the best way to handle this edge case and add it to your pseudocode. Then once you're happy with your plan, you can move on to the implementation phase. As this phase, you will implement your algorithm in a programming language. When structuring your program, you should write modular code that is easy to read and understand. Use the tools of the programming language based on your current knowledge. Some programming languages include built-in solutions for common problems and tasks. Use them if possible. To be consistent, follow the best practices of programming language of your choice. Test your code as you write it and make sure that you are handling edge cases appropriately. Once your solution is implemented, test if it works correctly for all the examples and potentially refactor your code to make it clearer and more simple. Going back to your solution is very important. Development is not necessarily a linear step-by-step process. You can always go back to your code and use your critical thinking skills to improve it. These are some common problem-solving techniques that you can follow to approach algorithmic challenges. If you practice consistently, you will gradually develop your problem-solving skills. Which of the following is the most important first step when approaching any problem-solving challenge? Understand the problem statement, inputs, and constraints. Search for existing solutions online. Nope. Immediately start writing code. No. And guess the solution. So choice 1 is probably the best. What is the main purpose of writing pseudocode when solving an algorithmic challenge? To write the final executable version? No. To test the algorithm's performance and find bugs? No. To outline the algorithm's logic in a human-readable, language-agnostic way? I think that's the choice. And to automatically generate actual code for the solution? Nope. Before writing the final code for an algorithmic challenge, why is it important to consider edge cases? Edge cases are always the easiest part of the problem to solve. I don't think that's true. They help ensure that algorithms work correctly for all valid inputs. It might be true. They are only relevant for very simple problems. No, they make the code shorter. Nope. Choice 2. Let's check. All right. Again, these are pretty long theory sections. So this one here, we'll go ahead and do this one as well. How do dynamic arrays differ from static arrays? Arrays are fundamental data structures in computer science. All arrays store ordered collections of data, but depending on their type, they may work differently behind the scenes. Their underlying behavior can have an important effect on the program's efficiency, so let's learn about the dynamic and static arrays and their differences, so you can choose the most efficient one for your program. Let's start with static arrays. Static arrays are fixed size. They store elements in adjacent memory locations. The size of a static array is determined when the array is initialized. Once the specific block of memory is allocated, it's fixed and cannot change while the program is running. This is a key characteristic of static arrays. Storing elements in adjacent memory locations makes the data retrieval process more efficient because the program can store the location of the first element, then use indices to make simple calculations and find the other elements in memory. Thanks to this, accessing the value of a static array takes constant time, which is very efficient. So this O1. You can use a static array when you know the number of elements that will be stored in advance. It's also helpful when the values will be accessed very frequently since the access operation is very efficient. However, this data structure cannot grow or shrink, so if the number of elements that will be stored can vary, you should use a dynamic array instead. Trying to increase the size of a static array would involve increasing or creating a new array and copying all the elements from the old array to the new array, which is inefficient. In that case, a dynamic array would be much better because it handles this process automatically. Python does not include traditional static arrays as built-in data structures, but other programming languages like Java do support them. This is an example of a static array in Java that can store 3 integers. So the array is an integer array called numbers. I know a little Java. And then you're saying, I want a new integer array to store 3. So basically you're saying my variable is going to reference an integer array. And here is the new integer array with its size. And arrays in Python are dynamic, so let's take a look at those. Dynamic arrays are more flexible because they can grow and shrink automatically while the program is running. They work through an automatic resizing mechanism that copies the elements into a new array when the original array is full. The process is done efficiently because the size of the new array is chosen in an efficient way that makes these computationally inexpensive operations less frequent. Accessing the elements of a dynamic array takes constant time. So this operation is very efficient. Inserting an element into the middle of the array takes linear time because the elements after it need to be relocated. And inserting an element at the end of an array takes constant time if there's still space available in the dynamic array. But if the array is full and needs to be resized, this operation has a complexity of n. You should use dynamic arrays when you don't know in advance the number of values that you will need to store in the array. They're also helpful when you will be frequently inserting and deleting elements. Python's built-in list data structure works as a dynamic array. You can create a list by writing the elements within the square brackets separated by columns. So there's our array or our list example. It's also an array. You can access an element by writing the name of the variable that holds the list, followed by square brackets, and within the square brackets, the corresponding index. Indices start from 0 for the first element and are incremented by 1 for each subsequent element. I think we're familiar with this at this point. To update the value, you just need to reassign it. So the third element, which is indices 2, we want to make it 16. You can append elements to the list with append method. So we're going to put 7 at the end after 6. And you can insert elements at a specific index with the insert method, passing the index as the first argument and the element itself as the second. So in our numbers list, we want to insert the number 15 at index 3. You can remove an element at a specific index with pop method. So we remove the third element in index 2. If you don't specify an index, it will remove the last item. There are other built-in list methods that you can check in the documentation for adding or removing elements quite easily. That's the power of dynamic arrays, or lists in this case. In general, you can use static arrays when you know the number of elements in advance and you need to access them frequently, and use dynamic arrays when the number of elements is unknown or variable over time. You should always consider the trade-offs between simplicity of static arrays and the flexibility of dynamic arrays. They're both helpful for specific use cases and scenarios. Being able to choose the best one for a given problem is part of the problem-solving skills that you will gradually develop with practice. So what's the main difference in size between a static array and a dynamic array? Static arrays can change their size. Not true. Static arrays are fixed. That's true. While dynamic arrays can change size during runtime. That's true. There's no practical difference. It's not true. Dynamic arrays are always larger. Nope. If you need to add more elements to a static array that are already full, what is the typical process? Static array automatically expands? No. You must create a new larger array and copy all the existing elements to it. I think that's true. Array automatically converts itself into a dynamic array. That's not true. New elements are simply discarded if the array is full. That would be very unhandy. Which scenario would a static array typically be more suitable choice than a dynamic array? When the exact number of elements is unknown and changes frequently. when you need to store a very large data set that grows indefinitely. No, none of those are good for static arrays. When you require frequent insertions and deletions at arbitrary positions within the collection, and when the data size is fixed and known at the time the program is written. That's right there. All right, so 3 out of 6 down. We're going to be done with this one. So these are taking a little bit longer, so I was thinking it was going to be 2 days. This may be more like 3 or 4 days to get these done. These are important things, and hopefully we do. The practice is very reinforcing. There's a good book, and I can't remember the name of it right now. I'd have to go look on my bookshelf. But there's a good language agnostic book that actually uses Python, I think, to explain this, sort of, because obviously you can't explain static arrays very well with Python. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.